Welcome to 6E, which is recognizing a complex algebraic fraction. And simplify it as if it was a quotient or product or simple algebraic fractions. Pretty much a complex fraction is what we're looking at today. Steps for this. For example 1, we have a complex fraction is just many fractions put into one big fraction. First step you should look for is combining fractions with additions or subtractions. So up on the numerator here, I have 3 over m plus 3 over 25. I need to combine those and make it one fraction. So step 1, first, combine fractions with addition or subtraction. So to combine these, we learned earlier on in chapter 6 that to combine two fractions, you have to have like denominators. So the left denominator, just to make this easy, multiply by the second fraction's denominator, numerator and denominator. Second fraction, I'm going to multiply by the first fraction's denominator. And now I'm going to end up rewriting this. So I have 25 times 3, 75, over 25 times m, which is just 25m. I have 3 times m, 3m, over 25 times m. This is still all over m squared. But I'm not really worried about the m squared right now. I'm combining the numerator into one fraction. Right now we have like denominators in the numerator, so we just combine 75 plus 3m, not like terms, so we just write them 75 plus 3m over 25m divided by m squared. At this point, we have a fraction over fraction, and what we're going to do is end up doing KCF, but it might be easier to look at it at this fraction, this complex fraction, as you take 75 plus 3m over 25m. And this division right here, this division, I'm going to write it division of m squared. But we want to make that fraction, so you divide by 1, that'll make that a fraction. So now this is exactly like 6D part 2, where you have keep it, change, and flip it. So I'm going to change this to 75 plus 3m over 25m. So keep it, change it, flip it. Now we factor every numerator and denominator separately, what you did in 6D part 2. The first 75 plus 3m, I can factor out of 3. Everything else is a monomial, so I cannot factor it. And I look to see if there's anything on my numerators and denominators that I can simplify. 3 over 25, no. There's an m in the denominator, no m in the numerator by itself. Does not look like it, so now I'm just going to combine all numerators and all the denominators, multiply them together. And since I couldn't simplify anything, that is my final answer. So after, going back up to the steps, after the first step, second step is to do KFC, keep it, change it, flip it. And then third, factor completely. And fourth, simplify. Now, as we saw, simplifying is not always can simplify, but we always try. Moving on, example 2. Here again, I'm looking for first thing, to combine fractions with addition or subtraction. I see a subtraction in the denominator, so I'm just concentrating on the red, what I circled there. I need to get those fractions together. So to combine fraction with subtraction, you have to get like denominators. So I'm going to take the second denominator's fraction multiplied by the first fraction. First fraction's denominator multiplied by the second fraction. And I'm going to rewrite everything. 3a over 5, big division. 9 times 3 is 27 over 9a, minus a times a squared is a to the third over 9a. We have like denominators. Now I can combine those like denominators. Again, I'm only looking at the denominator. My numerator is still saying the same, 3a, the numerator's fraction. Still saying the same. Denominator, we have 27 minus a to the third over 9a. Now I have two fractions. That's now we change that to keep a change and flip it. So we keep the 3a over 5. So this is the k, c, f. Keep it 3a over 5. This is also a division here. That's the division. So you change it to a multiplication and flip the second fraction. Now we look to see if we can factor anything. We have monomial, 3a is a monomial, can't factor that. 5 is a monomial, can't factor that. 9a is a monomial, can't factor that. And 27 minus a to the third, you actually can factor it. This is using the difference of cubes. Cube root the first term, you get 3. Cube root the second term, you get a. So if you think back, we have a, so 3 minus a times 3 squared is 9. This is the slope thing also, it's the opposite. 3 times a, and then always positive, plus a squared. Now you're going to see I factored everything, and now I look to see if there's anything in my numerator and denominator that are same that I can simplify. And unfortunately, again, I don't see anything. So the final answer, I would just multiply out the numerator. 3a times 9a, 27, a squared over 5. I would never, I don't multiply out the denominators. Never see a need for it, never see anywhere you need to have it. And that will be it. For your exit, or your entrance ticket, your warm-up ticket, you are going to have both these examples on your warm-up ticket. If you have the notes, you'll be able to copy this down, and you will have 100%. Come to class with questions. Thanks.